All right, I believe we were on page 35, right? Talking about these piecewise functions. I forget which one we left off on. Were we on 1 or 2? 2. We finished 1. Okay, so we have to start 2 completely. All right. From yesterday, I think I told you guys how I'm used to doing these. If you don't like the way I approach it and you're more familiar with a different method or process that works for you, you do you. Okay, as long as you can have the appropriate graph, I don't care how you get there, as long as you can get there in the end. Okay, but I'm going to do it the way I'm used to, so that's what we're going to do today. If you take a look at number 2, we're going to start with looking at the domain sections of these different pieces. Notice how each domain piece is kind of involving that number x value of -1. So I'm going to draw a little barrier at -1. Have we heard the word asymptote before? Does that sound familiar? For some reason, when I was in high school, I always thought that word was kind of funny. Yeah.
We didn't finish number 1.
We didn't finish number 1.
We didn't do the second part.
Oh, we didn't do the second part. Oh, okay. We'll come back to number 2. All right, so let's see. We had the barriers for this one. And we graphed the parabola. Is that right? Okay, so we plugged in 1. We got out 6. Plugged in 4. Got out 1. Found the vertex. So that's all we have right now, right? Okay. Let's go ahead and graph the second piece. Okay, we're going to plug in -4 into our equation to get kind of a starting point. If we plug in 4, 2/3 times 4 is 8/3, and then we got to add 2. So we might do a little fraction work here. To add fractions, you got to get a common denominator. So we can rewrite 2 as 6/3, add the tops, keep the common denominator. And 14/3 is the same as 4 and 2/3 if you want to write that as a mixed number. Okay, 3 goes into 14 4 whole times, which would be 12, but you have 2 left over because you have 14. So if we plug in 4, we get out 4 and 2/3, aka 4.667. Thanks, guys.
Happy birthday.
Happy birthday.
Why didn't you tell me?
All right, so we plug in 4, we get 4.667. Might be a little hard because your graph is, the lines are kind of really close together, so it might be difficult to graph that point. But we can at least roughly guess where it would be. Open circle because there's no bar. Okay? So what's a little different with this little piece compared to the parabola we did was we only have 1 point kind of guiding us now, whereas the parabola we had 2. Okay, so we need to somehow figure out another point in this section to help us figure out which way our graph is going. Okay, if you take a look at your equation, what type of shape should we be anticipating? What type of equation is this? What would the graph look like? Two-thirds x plus 2. Mx plus b, yeah. It's going to be a line, okay? So let's think about this. If you were to graph any line, okay, way back in Algebra 1, you would normally start with the y-intercept, right? That number 2, okay? But if I were to place a little dot there at that number 2, am I in the correct region of my graph? No, because we said we're only graphing it in the third section, right? So typically I would start there, but I know I can't because I'm not in the right section. After we would plot that point, we would then use the slope, right, to get another point. So if I could plot a point there and then do up to right 3, I would have another point right there. Am I in the correct region? I'm still not, right? So let's try that again. Let's use the slope. Up 2 over 3. Am I in the correct region now? Yes. Okay, so let's go ahead and plot that point. Okay, so if it's a line, you know you can try to graph a line like you normally would, but you got to plot the point in the correct spot. So we're going to play connect the dots with this open circle and the new point we found using a linear graph, okay, a straight line. So there's our first piecewise function. There's nothing showing up on the left like we labeled yesterday. The parabola is only showing up in the middle like we said it should, and the linear function's only on the right. Okay, everything was nice and organized because we took the time to label everything. Okay, that's what we're going to do for number 2, and we kind of already started doing that. Okay, we drew in the barrier for -1, and then I started talking about asymptotes for a second. So we've heard that word, right? When I was in high school, I always thought that word was funny because it was like kind of my way of swearing, right? Asymptote. I thought it was funny. Yeah. Okay. Anyway. Okay. So the first equation, notice how it's going to show up to the left of -1, so we can label that appropriately. The second equation's going to show up at -1, okay, and that's the only place it's going to show up. So that's going to be right on the barrier. And then the third equation is going to show up to the right of -1, so that's the entire right-hand side. Okay, so the reason I brought up asymptote, and it's good that you guys have heard that before, is typically on a graph we draw an asymptote with a dotted line, right? Vertical dotted line. I just want to make it clear that this barrier I'm drawing is not a vertical asymptote. I know it looks like one, okay? If you want to make it a solid line, you could do that if you wanted to, okay? But this is not an asymptote. You can think of it as a fence, as a wall, some type of division separating the graphs, okay? This is not an asymptote. All right, so now that we have it nice and organized, let's go ahead and try to graph our first piece here. If you were to plug in -1 into your equation, -1 plus 2, we got 1. Absolute value of 1 is still 1, right? And then plus 1, we would get 2. So let's go ahead and plot that point. We plug in -1, we get out 2, open or close circle. Open, good. Okay. Now we kind of have the same issue as the line from the last case. We only have one beginning point. We need another point within this section to help us guide the graph, figure out kind of where else this graph is going. So if you take a look at this first equation, it's an absolute value, which means we should be anticipating a V shape, right? Like we've talked about. So maybe we can figure out where the bottom or the vertex of that V is. Okay, we'll try to figure out that guiding point. And we're going to use the transformations to help us figure that out. Okay, based off the way that equation looks, can you figure out how that V moved? Typically it starts at the origin, okay, 0, 0. But how did it move based off the equation? What do you think, Alex? It is a slope of 1. Okay, so the stems or the legs of the V have a slope of 1. We're not vertically stretching it. What do you think, Aiden? Left 2, up 1. Okay, so typically the vertex starts at the origin, but if it moves left 2 and up 1, the vertex is now there. Okay, so if that's the bottom of your V, we need to play connect the dot a little bit on the right-hand side. Okay, that's the one side of the V. And then the other side of the V is just going to continue forever to the left, having a slope of 1, like Alex mentioned. Okay, we're not vertically stretching it. We're not making the legs steeper. Okay, slope of 1 on the left-hand side. All right, so it does look like a V, but since it's chopped off, it looks more like a check mark, right? Because we have that barrier there. Okay, let's try the next one. If you were to try to plug in -1, notice how there's no x value for you to actually plug in that number, or -1, 2. All right, so if we tried to plug in -1, what are we going to get out? Not quite. All you have is a 3, right? Okay, so if there's no variable, remember variable is something that changes somehow. If you think about your science classes, a variable changes. If there's no variable there, the number will never ever change. So you could try to plug in -1, you could try to plug in 5, you can try to plug in 7. It doesn't matter what you try to plug in because the number will never ever change. It's always going to remain 3. Does that make sense? Because there's no variable. So if we try to plug in -1, we're going to get out 3. There's no way that that value will change. So graphically speaking, try to plug in -1, we get out 3. We would have a closed circle because we're actually equaling -1. Now that's the only portion we need to graph because we said that second piece should only show up on that barrier. So all we really have there is a point. There's no graph or line to draw. Okay, we just have that closed circle there. All right, let's try the last piece. If we try to plug in -1, -1/2 times -1 would be +1/2 plus 5 is 5.5. So we'll plot that point. -1, 5.5, open circle, right? Okay. Let's see, our third piece looks like a line, mx plus b, so let's try to graph a line like we normally would. If you were to plot the y-intercept of 5, are you in the correct region that you labeled on your graph? I think so, right? Right? Because the third equation should be to the right of that dotted line, which that point is. Okay? So you can use that point and the open circle and draw your line if you wanted to. Maybe some of you want to be a little bit more accurate. You can then use the slope, down 1, right 2, to get another point. If you think that the original 2 points are too close together. So we're going to have a line on the right-hand side going forever. Okay, so everything's checking out. We have that V shape on the left, we have that point right in the middle, and then the line on the right, just like the domain's telling us. Are we starting to get the hang of these a little bit? Okay, let's go ahead and step it up a bit. We're going to take a look at some square roots at the bottom. Let's go ahead and section off our graph. Take a look at your domain sections. We are dealing with -4 and 0. Let's see, the first equation is going to show up between -4 and 0, so you can label that on your graph. The second piece is going to show up exactly at 0, so it's going to be on that barrier. And the third piece is to the right of 0, so completely on the right-hand side. So that means we have absolutely nothing on the left. All right, let's go ahead and try to plug in -4 to get our first point here. If we try to plug in -4, notice how the negative on the inside would change it to a +4. The square root of 4 is 2, plus 3 is 5. So we can graph that point, -4, 5. Closed circle because we have a bar, right? Okay. The next domain value we can check is 0. The square root of 0 is 0, and if we add 3, we'll just get 3. And it looks like we'll need an open circle. So 2 points are always nice because you know you're going to have to connect them somehow, but you got to make sure the way you connect them is appropriate for the equation that you're drawing. So notice how we have a square root equation. What does a square root graph look like? Can you describe the shape somehow? Or maybe use your finger to kind of show it. Sydney's doing it. Yep. Okay. So we have some type of starting point, and it curves off from there, kind of like a sideways parabola. But depending on if you reflect it at all, sometimes it can go in different directions, right? Okay. So what's happening here is if we're going to connect these 2 points in that curved fashion. Now, hopefully we can anticipate that the graph should have the curve like I drew it because we have a negative on the inside. And which way does that reflect our graph? Are we taking this square root shape and reflecting it over the x-axis so it's upside down, or over the y-axis so it points the other direction? Negative on the inside? Which one is it? Y. Good. Okay, so if we're reflecting across the y, it should have this shape. So it makes sense that we should start here and curve that way. Okay, so there's our first piece. Let's go ahead and take a look at the next one. If we tried to plug in 0, there's no variable there to actually plug it in 2, so that number of 2 will never ever change. We can plot that point, 0, 2, close circle because we're equaling 0. Alright, and our last piece, if we try to plug in 0, square root of 0 is 0, plus 3 would be 3. If we plot that point, 0, 3, it's already there, right, that open circle, but do we have to fill it in? No, because this one's still open as well, right? Okay, so we still have this point, but since that's the only point that we have, we need to try to figure out where is there another point on this side to kind of help us. Now, this is not a line, so we can't start at the b value and then use a slope. Okay, it doesn't exactly work that same way. But what's nice is this domain is telling you you can pick any number you want as long as it's greater than 0. So pick any number you want bigger than 0 to plug into that equation, okay? Maybe 1, maybe 4. Something strategic because you're using a square root, right? Something you can easily take the square root of. So pick any number you want bigger than 0 to plug it in and get a point to help guide you. Okay, you want to try 1, like Matt said? Okay, let's go ahead and try 1. If you plug in 1, square root of 1 is 1, plus 3 is 4. So let's graph that point, 1, 4. Okay. So again, keeping that starting point and curving off, we need to connect that open circle to the new point we found and then curve off to the right. Notice how we have no graph on the left. We have our first square root in the middle. We have the lone point on the barrier and the other square root on the right-hand side, just like we said we should. We doing okay? All right, let's try 4. Let's go ahead and section our graph. We have -2 and 1. Based off the domain, the first equation is going to show up to the left of -2, so that's the entire left-hand side. The second equation is going to show up between -2 and 1, so that's between your barriers. And the last equation is going to show up bigger than 1, so that's everything on the right. Okay, so now that we have it organized and sectioned, let's go ahead and try to find some points. If we were to plug in -2 into the first equation, -2 would become positive, -2 is now 0, square root of 0 is 0, plus 2 would give us 2. So we plug in -2, we get out +2, and we need an open circle, there's no bar. Okay, we only have one point, so we somehow need to figure out Where is there another point in that first section to help us guide this square root graph? So pick any number you want smaller than -2 to test it. What do you want to try? -3? Okay, let's check out -3. -3 would become +3. -2 is 1. This one's going to work out nice. The square root of 1 is 1. Plus 2 is 3. So we plug in -3, we get out +3. We can plot that point. So we have that starting open circle, we have our guiding point, and we're going to curve off to the left because we have to stay in that first region we labeled. Alright, let's try the next piece. We plug in -2. -2 times -2 is +4, minus 2 is 2. Let's see, if we try to plot that point, -2, 2, we already have an open circle there, but do we need to fill it in? No, because there's no bar. Okay, so this open circle is the beginning point for our new piece. Let's go ahead and try to plug in 1 to get another point. -2 times 1, -2, and then minus another 2 would give us -4. So plug in 1, get out -4, and we have an open circle there too. So 2 points are always nice because you're just going to play connect the dots. You have to make sure you connect them appropriately. So how are we going to play connect the dots? Straight line, curve, jagged, straight line, right? Because we have a linear function. So go ahead and play straight line, connect the dots. Alright, our last piece, let's go ahead and plug in 1. 1 minus 1 is 0, square root of 0 is still 0, opposite of 0 doesn't even matter, minus 4, we get -4. So we plugged in 1, we get out -4, looks like we're landing on this other open circle. Okay, so that's kind of a beginning point for us to use. But again, we only have 1 point, so we have to try to figure out where is there another one in this section to help us guide the graph. Okay, so pick any number you want bigger than 1. 2? Okay. 2 minus 1, 1. Square root of 1, 1. We need the opposite of that, so it'd be -1. Minus 4, we get -5. So let's plot the point. 2, -5. Beginning point, guiding point, and the square root kind of curves, so we're going to go off to the right. We hanging in there? Alright, so that's the last piece for this section. If you take a look at your homework, hopefully, we're not done yet guys, okay, I'm just showing you something. If you take a look at your homework, hopefully you've already done the first 6 graphs, okay, because we've talked about those previously. Yesterday we did ordered pairs, so you should be able to do 7 through 9. And number 10 is a piecewise function for you guys to practice, okay? So the homework assignment for this section I think should go fairly easy for you guys. All right. We are going to go on to page 39 though. We're going to start the next section. We're not going to finish it today. But this is going to be a review kind of for us. You're going to see some things that we did at the beginning of the year. Want to bring them back ever so briefly because we're going to expand on them the rest of this week and next week. So let's just make sure we're all on the same page. Okay. If I told you f of -4, what does that notation tell you to do? What does your gut tell you to do? Good, Aiden? Plug -4 in for x. Okay, so the function or equation we're going to use is at the top. Let's go ahead and plug in -4 for x. Alright, I'm not going to give you the play-by-play, the step-by-step, because I think we're good with this. I don't want to insult your intelligence. So go ahead and you can solve from there. Hopefully we can get 2. Agreed? Okay. Go ahead and try the next 2 questions. Plug in -1, see what you get. Plug in 0, see what you get. Bless you. We get 4 and -14. Working out? Oh, I'm sorry. Yeah. Thank you. That makes a difference. -4, -14, better? All right, good. Okay, so I know you've been doing that for years, plugging in a number, getting out a number, but what we're going to focus on is what do all these numbers mean? What do they represent? How are they all connected? Okay, so you're used to computational math, plugging in numbers, getting out numbers, okay, but we need to understand what all of this is telling us. So, when you found the value of f of -4, okay, for instance, this first one in the table, what does your result, aka answer, represent? What does this number 2 mean? And I'm specifically wondering in terms of a graph. What does that number 2 mean? What do you think? An x-intercept. Well, let me ask you this. We said this was an x value, right? If I were to plot an x value of -4, what does this 2 represent? What do you think? It's a y value, right? So if I plug in -4, I get out 2. That's not quite an x-intercept. Okay, we're going to talk about x-intercepts in a little bit. Okay, but graphically speaking, the result, your answer, when you plug in an x value, should be a y value. Okay, so f of -4 is the y value when the x value is -4. So graphically speaking, we have this ordered pair or point. If your x value is -4, your y value is 2. You can do the same logic for the other 2 that you did. Okay, so speaking of the other 2, here's the parabola of this quadratic equation that we had at the very top. Okay, upside down u, because notice how it's negative. Okay, we flipped it over the x-axis. Do your answers or results from f of -1 and f of 0 make sense graphically? Okay, in terms of this graph. So we said, based off of before, that this -4 should be a y value, and this -14 is a y value. So are the points -1, -4, and 0, -14, are those on your graph? Can you identify those? Yeah? -1, -4, notice how that's on the parabola, right? Can we see 0, -14 though? Not quite, okay, because that's your y-intercept. We don't really go down that far. Okay, so do the results make sense in terms of the graph? Well, I'd say yes. Okay, explain why or why not. Because the point -1, -4 is on the graph, and the other point, 0, -4, we'll say looks like it would be on the graph. We can't really tell, but based on the way the graph is traveling, okay, notice how it's kind of very steep towards the bottom right there. It looks like it would eventually cross at negative 14. Okay, it looks like it would. So you've been doing computations, plug in a number, get out a number, okay? But what does that all mean graphically? We are plotting points, finding specific locations where a graph is located, okay? All right, so Cole, speaking of x-intercepts, okay, the graph of f of x has two zeros. Do we remember what that word zero means? Yeah? Go ahead, Cole. Okay, so 0, root, x-intercept, those are all synonyms. We looked at that at the beginning of the year on the calculator. Okay, we saw how we can find those exactly with the capabilities of our graphing calculator. All right, so speaking of x-intercepts, the graph clearly crosses the x-axis at a value between negative 4 and negative 1. So if you look on the graph, there's negative 4, there's negative 1. Notice how the graph touches the x-axis at some place in between those, correct? We can see that? Okay. Based on your computations, okay, so the little work you did up at the top in the table, how would you justify the guaranteed location of this x-intercept? How do you know for sure that you know there is one between negative 4 and negative 1? We don't really know what it is, okay, it's going to be some decimal value, but how do you know that there's one there for sure? Let's say we didn't have the graph, okay, we're looking at this work. How do you know that there's one between negative 4 and negative 1? Let's see, when you plugged in negative 4, you got 2. When you plugged in negative 1, you got negative 4. How do you know there's an x-intercept between those 2 points? Let's think about this. Okay, x-intercept and 0 are synonyms, right? Okay, so at an x-intercept, the y value should be 0. That's why it's called that. It's a 0, a y value of 0. So take a look again at your computations. If you plug in negative 4, you get out 2. If you plug in negative 1, you get out negative 4. How do you know there's an x-intercept between those points? We honestly don't know. I see smiles, like I know you guys know what's going on, or at least I'm hoping. Or we honestly have no idea. No, honestly, no idea. Okay. If you plug in negative 4, you get out 2. If you plug in negative 1, you get out negative 4. Is the number 0 between 2 and negative 4? Yes. So, since the y value of 0 is between this y value of 2 and this y value of negative 4, then there must be an x-intercept between this x value of negative 4 and this x value of negative 1. Does that make sense? Now that we see that. Okay? So x-intercept and 0 mean the same thing. You're looking for a y value of 0. So let's go ahead and maybe write that down. Let's see. F of negative 4 was 2, and f of negative 1 was negative 4. So there must be an x-intercept between negative 4 and negative 1, since 0 is between 2 and negative 4. Okay, so there must be an x-intercept between the -4 and -1. Okay, the numbers you plugged in, those are x values. Since 0 is between 2 and -4. Okay, those y values you got out. Right? Make sense now? Okay, so speaking of x-intercepts, based on the graph, we said we cannot determine exactly where the zeros or x-intercepts are because they don't cross at nice ordered pair points. But maybe we can figure out roughly between which x values these x-intercepts are located. So if you take a look at your graph, try to plot the points where it crosses the x-axis, or at least touches the x-axis. Between which two x values should we anticipate these x-intercepts to be located? Can we find them? Go, Tyler.
It would have to be between -5 and -4.
Between -5 and -4.
And then
Uh-huh.
between -1 and -2.
And -1 and -2. So tomorrow we're actually going to figure out where they are exactly, okay? But for now, we at least know we should anticipate some decimal between those two values and these two values. Okay? Hanging in there? All right. For this section, okay, a few homework problems you could probably do because plugging in numbers, you guys are used to that, easy to do. 1 through 4 probably on page 43 and maybe even 5 and 6. Okay, so a few homework problems to do tonight, or at least try tonight, get to them.